Okay, so I give you C of T, which is ounces. How many, let's see, how water is dripping through a coffee maker, filling a large cup with coffee. How water? What the heck? Hot water. I'm supposed to say hot water.
Ow.
Hot water is dripping through a coffee maker, filling a large cup with coffee. The amount of coffee in the cup from 0 to 6 in terms of time, minutes, is given by a differential function C. So C is an amount. Select values of C are given. Part A, use the data in the table to approximate C prime of 3.5. What do I do? I'm trying to approximate C prime. So we're just going to say C prime of 3 is approximately, what did I say? C prime of 3.5 is approximately C of 4 minus C of 3 over 4 minus 3, which is, what's C of 4? 12.8 minus 11.2 over 4 minus 3, so that is 1.6 over 1, so we'll say 1.6. Does it ask for units? It says indicate the units of measure. So what's the units on C prime if C is ounces? Ounces per minute. So that is part A. Okay. Part B is where the mean value theorem applies. Because we are trying to explain why C prime of t equals 2 somewhere. Is there a place where C prime of t could be 2? Be in the interval 2 to 4. Okay? So we're going to say, this is where we explain. We say C is differentiable. C is differentiable. Therefore, C is also continuous. And we could say, therefore, the mean value theorem applies. The mean value theorem applies. Okay. And what would we do with that then? We'd say, we'd say C of 4 minus what? C of 2 over 4 minus 2 is equal to 12.8 minus 8.8. Thank you. So you got 4 over 2, which is 2. Because it gives you the interval 2 and 4. So since the function is differentiable from 2 to 4, and it's continuous from 2 to 4, that means the mean value theorem applies. What's the mean value theorem say? It says C prime will equal the average slope somewhere in between the endpoints, right? Since the endpoints are 2 and 4, and the endpoints produce an average slope of 2, that means C prime must be 2 some point. So the answer is what? Yes. Yes, C prime of t equals 2. Not over the interval. For some t within 2 to 4, I guess. Actually, yeah, I guess closed interval. Okay. Okay, so it's important that you qualify the mean value theorem, so you have to explain the caveats, the hypotheses of the mean value theorem. You have to, in order for the mean value theorem to work, it has to be differentiable and continuous. So you have to state the mean value theorem will work because of that. Then you have to show the average slope between the endpoints, and then you have to say yes. Okay? Any questions on that one?
Well, don't you have to say yes because it will be 2?
What? Okay. So part C, the amount of coffee in the cup in ounces is modeled by B of t equals that. Using the model, find the rate at which the amount of coffee in the cup is changing when t equals 5. So B of t is what? It's the amount of coffee. What did C of t represent? the amount of coffee. They represent the same thing. It's just C of t is a table and B of t is a function. But in this case, we're using the function B of t. So how do I find the rate at which the amount of coffee in the cup is changing? Take the derivative. This is easy. Can I get rid of this? A and B? Yes? Okay. So part C, let's find B prime of t. What's B prime of t? 16 is a constant, so we're going to multiply, well, what's the derivative of exponential? It would be negative 16 e to the negative 0.4t, what, times negative 0.4. So we'll simplify that a little bit. Is this a calculator problem? I don't know.
Yes.
I don't think it is. So it'd be 6.4 e to the negative 0.4t. And now what is it asking for? Find the rate when t equals 5. So b prime of 5 equals 6.4 e to the negative 0.4 times 5, which is 6.4 e to the negative 2. So I could just simplify that a little bit by saying 6.4 over e squared.
And if it's the FRQ, that's 5.
Yes. Amount of coffee in the cup, okay. And it didn't say indicate units, did it? What would the units be? Ounces per minute. What? Wouldn't that automatically mean that I need to put units? No. Yeah, in theory, you should be as detailed as possible. But I think in part A, they asked for the units, and it's the same unit, so you don't worry about it. But that's it. Okay. Any questions?